All right, guys, everyone is here. Wow. Yeah. How are you? How are you guys? How is everyone? We have Zeb, Saad, and Umer. How are you
Yes,
doing, Zeb?
you're good.
Alhamdulillah, fine, sir. How are you?
I'm doing good. Saad is also doing fine. Nice to hear that. How is Umer? Umer is with us here. Umer, are you here with us? Okay, let's let Umer join, and until then, let us. All right. Okay, so Zeb, last two classes you are not here with us. So in the last class, we were discussing about how we are going to proceed with our syllabus now. Okay, so in the last class, we agreed, me, Saad, Umer, agreed upon this thing that we would be taking up geometry part from coordinate geometry. Okay, Zeb, can you tell me which chapters you are you are done with in the school?
In the school, um,
Yeah, in school, which chapter?
binomials, linear equations into variables,
Mm-hmm.
statistics, probability,
Mm-hmm.
coordinate is going on,
Mm-hmm.
triangles is done, applications of trigonometry,
Okay. So what chapters are you left with?
circles, surface area and volume,
Circles, surface area, and volume.
arithmetic progression,
You're you're still left with arithmetic progression. Okay. And
and quadratic equations as well.
quadratic equations as well. All right. Can you hear us, Umar?
Yes, sir.
All right. Okay. Okay. So are you done with triangles, Zeb?
Yes, sir.
Okay. You're done with triangles. Trigonometry, you're done with trigonometry, right?
Yes.
Okay. And right now you're studying coordinate geometry, right?
Yes.
Okay. And surface area volume is also done?
No.
No, it is not done. Coordinate. Okay. Uh, Trigonometry is done. Applications of trigonometry is done. Triangles is also done, right?
Yes.
Triangles is done. So uh, quadratic equations is not done, and arithmetic progression is not done. Statistics is statistics done.
Yes, statistics is done.
Okay, and probability. What about
Probabilities is done.
also that is also done. Okay. All right. So I think taking up coordinate geometry would be nice because what we agreed in the last 2, 3 classes that we were here is that since these chapters are done for Umair and Saad in their schools, okay, the ones that I have written here, but I have marked Z and D for you that they are not done for you. So this is for you that it is not done. So these topics were done mostly. Algebra was done for Umair and Saad. So we decided that we will go ahead and start coordinate geometry and triangles, applications of trigonometry, and in general geometry, that we would be working on geometry. So since uh, it makes sense to start with coordinate geometry, and we did discuss a few things. Which exercise are you guys doing in coordinate geometry right now in school? Are you done with the chapter, or
And we
about to
have
be
to
done?
start. After exams, she will start.
Okay, after the exams you will have to start coordinate geometry. Okay.
Yes.
Okay, all right. Okay, so you haven't started coordinate geometry yet. Okay.
Mm.
Okay. Okay, so what we did in last class was we started coordinate geometry. We discussed a few questions on them, and then I also had given homework to, I think Umair was there in the last class, right, with coordinate geometry, or was Saad also there with us?
Yes, sir. Both of us were.
Both of us were there, right? Okay. So what we can do right now is what we did. We discussed questions from the exemplar, right, in the last class.
Yeah, we did exam plan.
Exemplar questions. Okay. So let's take a brief. What we can do in this particular class is that we can take a brief, introduction and sort of attempt to, summarize coordinate geometry for Zab also. And then we can proceed with questions. And from the next class, we can all be on the same pace. Okay. that would help uh, the three of us being together here, and we will be able to work fine. Okay, does that sound fair to everyone? Will that work?
Yes, sir.
Yes, sir.
Well, what about you, Sal? Will that work, man? Do
Yes, sir.
feel comfortable to let me know if we have to change anything in our pace and in our the approach to completing the syllabus. You do not really have to just be formal and be like, yes sir, we are fine with whatever you're telling us. Okay, feel free to share your own opinion also. Okay, so to start off, okay, you can pause me and tell me if you want to do something else, or go in a different way. For now, I think this seems to be the middle way, since Zeb is also going to be with us until the end of exams. Okay, so coordinate geometry, Zeb, what I would like you to do is that uh, have a we would be doing questions from NCRT and NCRT exemplar. Okay, you can download exemplar from the NCRT website. Have you heard about exemplar, Zeb?
Yes, sir.
Right, so exemplar does have decent questions. Okay, and you do not really have to do anything outside exemplar or NCRT for now. When you are done with the complete syllabus and you're very sure that okay, everything is covered now, at that point you have the liberty to then go ahead and solve RD Sharma or any other book that you're trying to do. For now, be very thorough with NCRT and NCRT exemplar. That is enough for board exams, and I believe everyone here is not really expecting to be a topper who scores 100 out of 100. We all have lives, we all have things to do, okay, apart from studies also. So I think everyone here is comfortable scoring a decent score, 90%, 85%, 95%. Okay, it's not going to make a huge difference even if you score 100 and do not get time to spend on any other thing. Okay, so stick to these two books. This is going to be enough, and do not really exhaust yourself doing endless questions from thick books, books that seem very scary. Okay, so we are going to stick with this. So let us in my approach from now on, and it has always been that, is that we will take questions to understand the concepts. Okay, so we'll do that to understand what we are going to study. So let me just take a few questions from NCRT, and then we will start with coordinate geometry, and hopefully we'll be able to catch up, and Zev will catch up with us soon. Let us do that. Okay, coordinate I think is in the seventh chapter. Okay. All right. Coordinate geometry is actually a very simple chapter. It won't really take as much time to get up to speed. Okay. Okay, let me just take up. Okay, is this visible to everyone?
Yes, sir.
Yeah.
Yes.
All right. So Zeb, the chapter of coordinate geometry has two formulas that we are going to use. Okay, there are only going to be two formulas. And if you remember these two formulas, the only extra thing that you would need to remember is going to be some basic geometry that is going to be, of course, very easy to handle. Okay, only two formulas, and that is it. That's going to be needed here. The first formula, or the exercise 7.1, this particular exercise is based on distance formula. Okay. This chapter is pretty straightforward. Nothing too complicated, nothing too tricky. Just two formulas and that's it. So distance formula is, as the formula suggests, we are going to calculate distance between 2 points. Okay. So distance between 2 points. Let's say we have a first point x1 and y1. Now the distance that we are going to calculate is going to be in the coordinate axis, as the chapter's name suggests. Coordinate geometry, that is going to be our thing. So A and B are going to be two coordinates on the coordinate plane. All right, and we are going to calculate distance between these 2 points. So how would we do that? So we have a formula for that. That's going to be called distance formula. So the formula is going to be something like this. AB is going to represent the distance. It's going to be a scalar value. It's going to represent length. Okay. Now this length can never be, you know, negative, right? Negative length can never be negative. It's sort of very uh, until then, until me and Zeb get to speed. Umar and Saad, you guys can do whatever you want to do right now. Okay. So, and if you have anything, any other questions regarding the chapter, if you're paying attention to the class, since you have already gone through these things, it's up to you to, do whatever you want right now, but related to mathematics. Okay. By the end of the class, I would ask you for whatever you have done. Okay. In the last 10 minutes. Okay. So don't really waste the 1 hour that we have here. Do whatever you want to do, but do make sure that it is accountable. Okay. All right,
Okay.
let's continue, sir. Yeah, sure, guys. Okay, I know you guys will do use your time well. Okay, so length can never be negative. So AB is never going to be negative. If you ever get AB negative, you will not get AB negative because the value of AB is going to be this. Okay, now one thing that you need to remember in coordinate geometry, you will be following this rule 12 and 21. Okay, so that would become clear in the next sentence x1 minus x2 whole square plus y1 minus y2 whole square. Okay, so what this 12 and 21 means is that you will either follow this pair, or you will either follow this pair. Okay, you won't write x1 minus x2 whole square, and then in the next part you cannot write 21. Okay, you either go completely with this or you either go completely with this. Okay, in both the pairs you cannot shift between these 12 and 21. The whole formula should be either in 21 or in 12. Okay, so this formula in the book is written in the pair of 21, x2 minus x1 whole square plus y2 minus y1 whole square. Okay, this is what is written in the textbook. You can use either one of them. Both are right, but you just need to make sure it should either be in 12 or in 21 pair. Okay, so this is going to be a distance formula. Let us take a simple question from this. Question number one. We have 2 points. Whenever you are solving questions here, any doubts in this, Zeb, in the formula?
No, sir.
No, this is literally going to be the formula. That's it. Okay. Based on this, we will solve questions. Just remember the formula and the signs here. Okay. Since we have a under root here, that is why we cannot have length as negative. If you're ever getting a negative value here, you cannot get a negative value because you're squaring, numbers here. So squaring would essentially eliminate, negativity here, negative aspect of the answer. Okay, so let's do question number one here. A is going to be 2 comma 3, B is going to be 4 comma 1. Okay, now this is our x1, this is our y1, this is our x2, and this is our y2. Okay, so to find the distance AB here, we would quite literally just substitute the values. We would go for x1 minus x2, that is much easier to remember, or x2 minus x1, anything. Okay, so 2 minus 4.
Minus x2.
All right, and then what will the next one be? 3 minus 1 whole square. Okay, so 2 minus 1 is minus 2 whole square, and 3 minus 1 is 2 whole square. This would give us 4 plus 4. This would give us root 8. Root 8 can be written as 2 root 8, 2 root 2. It can be written as 2 root 2, right?
Yes.
Right. Let's take another one. Um,
Sir, 1 second. I'm just writing.
yeah, sure. Take it down. Let me know if I'm going a little too ahead of my speed. Okay.
Done, sir.
Done. All right.
Yeah.
Okay. So the next one is A is minus 5 comma 7. We are solving this one now. Okay. And B is minus 1 comma 3. Okay. So this is our x1, this is our y1, this is our x2, this is our y2. Okay. So AB would be root over minus 7 minus of minus. Okay. Be very careful about the signs here. Okay. If you skip the sign here, this particular sign minus here, it would mess up your answer. So minus 1 minus 5 plus 1 whole square, 7 minus 3 whole square. So this would give you minus 4 whole squared plus 4 whole squared, right? This is going to be, so 16 plus 16, this is going to be root 32. So we can write this as 4 root 2. Yeah, or 32 is 2 times 5. So we can write it as 4 root 2, right? Right. Is this clear? We can write this as 4 root 2, right?
Yes, sir.
Okay. So this is the basic application of the formula now. Okay. And okay, solve this for me, Zev, and tell me the answer for this. Third one. Whatever answer
Sir,
you're
your
able.
voice is breaking.
My voice is breaking. Okay, let me see. Okay, is it fine now?
Yes, sir.
Yeah. Okay, solve this question number 3 for me and let me know the answer for this, whatever the answer is. Okay, I will solve it with you here on the screen also.
Okay, sir.
Umair and Saad, did you guys do the homework for the coordinate geometry?
No, sir.
The question numbers were from 10 to 21. Were you guys able to do
In the
that?
portal. In the portal.
In the portal, yes, the one that I uploaded on the portal. It was from Exemplar. I did mention that. Did you guys do that?
No, I didn't open the portal.
Arey baap re, you did not open the portal. And okay,
No.
but okay, even if you do not open the portal, I will make sure of doing this thing that I will let you guys know about the homework right in the class. Okay, from now on, because
Okay, sir.
sometimes it is becoming a mess, some sort of a mess if people do not open the portal, and then why go through that whole hassle. So please do make sure that you note down the homework in the end of the class. Okay, for now what you guys can do is go from question number 10 to 21, 10 to 20, solve whichever question you are able to solve, and mark except the area of a triangle question. Try to solve whichever question you can solve and let me know whichever one you are stuck on. Okay, until then me and Zeb will okay complete this thing. Okay, is that clear?
Sir, I'm in the class only. I'm
Okay.
doing this.
Yes, I know you're
With
doing
you.
it. 10 and you're doing this chapter with me.
Yes, sir.
Sir, I was
Oh,
doing trigonometry though.
you're doing trigonometry. Okay, do trigonometry then. Whatever you started doing, I did not let you guys know in the beginning. Now it's all right. Do whatever you're doing. And Saad, you can come carry on with us also here. Okay. What is the answer, Zab? Did you get 2 into root over a square plus b square?
Yes, sir.
All right. Okay. So you're getting the hang of the formula, right? Like how are we going to use it? Right.
Yes.
Okay. Let's proceed ahead then. Okay. Now find the distance between 2.0 and 36 and 15. Can you now find the distance between two towns A and B discussed in section 7.2? Okay, we will have to go back to that. But okay, let us do this thing here, this question here. Here we are being asked to find the distance between origin and this point, right, Zeb? We are given this point 0 comma 0 and 36 comma 15. Okay, let me write down this point. The point A is 0 comma 0 and B point is 36 comma 15, right? This is what we are given.
No, this is the question number 2.
Yeah, question number 2. Okay. Hmm. Okay, what happened to my pen here? Okay, can you guys see this? Okay. Okay, so we have these 2 points here. A is the origin,
Sir,
right, Zeb? Yep. Yep, Umar.
and I got my maths marks this time
You have a doubt?
today.
Do you have a doubt, Umar?
I got my maths marks.
So I think Umair is talking to someone on his end. Okay. So Zeb, this is our point A. Point A is our origin, right? Even though it is given as point A, it is our origin, and point B is going to be some point on 36 is going to be somewhere here, and then 15 is going to be somewhere here, and point B is going to be 36 comma 15 here, right? So whenever you are told to find the distance between this is called finding distance from origin. Okay. Finding distance from origin. When we are finding distance from origin, the formula AB, where A is this origin point and B is 36 comma 15, this formula becomes uh, we we write a formula like this. Okay, this formula becomes, why this becomes this is, the reason is that our x1 is this, y1 is this, x2 is this, y2 is this, right? X1 minus x2 is our formula. So if we substitute the formula here, 0 minus 36 whole square plus 0 minus 15 whole square. So this is basically 36 whole squared plus 15 whole squared. Okay, so this is basically writing root over x square plus y square. Okay, so finding distance from origin is going to be this. This is going to be the formula for that, or you can even use the standard formula and find the distance. Okay, let's go to next question. Zeb, did you get this?
Yes, sir.
Saad, what about you, man? Did you get this?
Yes, sir.
Yep. Okay. Now the third question is, determine if the points 1 comma 5, 2 comma 3 and minus 2 minus 11 are collinear. Okay. So what we are being asked is whether these points are collinear or not. So what does collinearity mean? Do you guys remember what does collinear mean? Sir, what does collinear mean?
All points should lie in the same
On the same line.
line. Yes.
Yeah. Collinear meaning being collinear. Like if this is a line, all the points should lie on this particular line. If that is the case, only then is that meaning collinear. So do you understand what collinearity means?
Yes, sir.
Yep. Okay. So if we have 3 points here, okay, let us imagine, let us write down these points: a 1 comma 5, 2 comma 3 and minus 2 comma 11. Okay, a is 1 comma 5, b is 2 comma 3 and c is minus 5 comma 11 minus 2 comma 11.
Minus 2 for my 11.
Okay, so thank you for that, Zeb. Okay, so we have this with us. So if we have to calculate, like how will we use the concept of collinearity here now in coordinate axis, in the coordinate geometry part? Okay, let me. Okay, so we have this with us 1 comma 5. 1 comma 5 would be somewhere around this is 1. So phi could be here somewhere. So here is our A, 1 comma 5, right? 2 comma 3 would be somewhere here if phi is here. So this is going to be our B, 2 comma 3 will be here. And then we have minus 2 comma 11. Minus 2 meaning 2 is going to be, minus 2 is going to be here. Let's say here, minus 2. Okay. And then 11 somewhere, minus 11 would be somewhere down here, right? Let's say minus 11 is here. So this is going to be a point C, minus 2 comma minus 11, right? Now if you look at the points in a geometric sense, like purely in a very practical sense, you can see that these points are not collinear, right? Collinear meaning these three cannot be on the same line, like not all of three. At least two can be collinear, but not all of them can be collinear. Either these two can be collinear, either these two can be collinear, or either these two can be collinear at the same time, right?
Yes, sir.
Yeah. So when you find the distances between them, what you will notice is that if you find the distance between AB, they are going to be the closest to each other. Then BC, they are going to be then that is going to be something else, and then CA is going to be something different. Okay. So for something to be collinear, they need to have equal distances, or how do I put it? Hmm, here you can see that they are forming a triangle, right? Here what you can say is, let me just search up the what do you call that particular, there is a particular um property to it for if 3 points are not
Sir,
collinear.
so
Yeah,
it should be AB plus BC should be equal to AC, then it is collinear.
what is that? That is what it is. AB plus
BC should be equal to AC.
should be equal to AC. Yeah. That is right. Exactly. Yeah. Yeah, this is the point. So if we have A here and B here and C over here, so the distance AB plus BC will be equal to AC, right? If they are collinear. Since these 3 points are not collinear, the distance AB and the distance plus BC will be less than or greater than AC. Okay, this would be something either greater than or either less than. But if they are collinear, this will be the case. Okay, so these are some specific criteria and specific cases of geometry that we will have to learn here in this chapter, and this is one of them, collinearity. Okay, so to solve this question in exam, it will be pretty easy. You will find the distance between AB, BC, and AC, and then you will compare what the property or what they are satisfying there. So if they're satisfying AB plus BC is equals to CA distance, this property, then they are collinear. If they are not satisfying, they are going to be non-collinear points. Okay. Okay. So is this clear?
Yes, sir.
You guys can solve it on your own also, because this involves just solving, for distances A, B, B, C, and CA, and then putting in our own filter to decide if that question is going to be true or not. Okay. Next question we have, determine whether these vertices, we have vertices A 5 comma minus 2, B 6 comma 4, and C 7 comma minus 2 are the vertices of an isosceles triangle or not. So isosceles triangle means a triangle in which two opposite sides have, two adjacent sides have same length, right? If we have a triangle A, B, C, here this side and this side are of same length. So meaning we should have something like this, AB is equals to BC. In that case, this is going to be a triangle, isosceles triangle, vertices of an isosceles triangle, right? Does that make sense? Yeah, Saad, does that make sense? Saad, are you
Yes,
here
sir.
with us?
Yes, sir.
Does this make sense to you? If this is the case, then isosceles triangle. You remember isosceles triangle, right? What an
Yes, sir.
isosceles? Yeah. So to solve
Yes.
this question, to check whether the vertices of an isosceles triangle, we will have to check for AB is equals to BC. If the length is equal to this length,
Yes.
then it's an isosceles triangle, right?
Because two sides are same.
Two sides are same, right? Any doubts, Zeb, in this particular problem? In fourth one?
No.
No, no, right? Okay. So see, as you guys can see, it's a pretty easy chapter. There's nothing complicated to this chapter. Okay. Uh, even if even when you start this in school, Zeb, this would be very easy until and unless the teacher doesn't bring in very complicated questions and tries to make it a chapter that it is not. Okay. Let's check question number 5 now. In question number 5, we are being told four friends are seated at points A, B, C, and D as shown in figure 7.8. Okay. Or okay, this is a coordinate axis. As you guys can see, you can call this x-axis. You can call this y-axis. Okay, you will have to now come up with points. Champa and Chameli walk into the class. Okay, Champa and Chameli walk into the class, and after observing for a few minutes, Champa asks Chameli, "Don't you think ABCD is a square?" Chameli disagrees. Using distance formula, find which of them is correct. Okay, so they're basically asking these A, B, C, D points. Okay, where the friends are sitting, whether this figure A, B, C, D is a square or not. This is the question here. Okay, so basically we will be finding what is the condition for a square. Zeb, what is how does a square what when do you say a figure is a square?
All four sides should be equal.
All four sides should be equal. So what will we do here? We will find the distance between all four sides here, right? This point A point would be 3
And
comma,
also the diagonal should be equal.
diagonal should be equal. Yes, diagonal should also be equal, right? Exactly. So 3 comma 4, 6 comma 7, this is 6 comma 1, and what is point C going to be? Anyone?
Let's see.
C is, it is 9 comma 4. If you cannot see it, maybe because
9,
of,
4.
yeah, 9 comma 4. Okay, so you will be finding AB is equals to BC is equals to CD is equals to DA. Okay, and then the diagonals are going to be AC is equals to DB. Okay, you will also find this. Okay, and this. So nothing complicated in this. Again, finding this and ensuring this. Umer was nice to mention this. Good of you to mention that, Umer. That you will also have to check the diagonals. If they are not equal, then this is not a square. This is a rhombus then. Okay. So this question is also again something that you can do on your own. You just need to apply the formula here. Okay. Next, let's. Any doubts in this, Zeb and Saad?
No, sir.
No. All right. Okay.
The
Then
length
question number.
formula or AB formula?
Then length formula, distance
Okay.
formula. Here the
Okay.
points are going to be A, B, C, D. So you will be finding distance between point A and B, then B and C, then C and D, and D and A. And then for the diagonals between AC and DB. Okay.
Okay.
All right. Sorry about that stretch. Name the type of quadrilateral formed, if any, by the following points. Okay. So we have 4 points here. And we are told to we are told to find whether they are forming any quadrilateral or not. Now, quadrilateral is a figure with 4 sides, basically. Right. So of course, all of these will not. It's not necessary that all of these will form quadrilaterals, because we will have to check if they're collinear or not. Right. So you will have to also ensure to check this particular condition there. If 4 points are collinear, A, B, you can come up with these conditions on your own also. All right. AB plus BC plus BC plus CD is equals to AD. Okay, if this is coming up in this particular part, okay, then you will say that these 4 points are collinear. So whenever you find the distance between these points, now whenever you're trying to find if they make a quadrilateral or not, the first step would be to see this thing. Okay, all right. If this thing is coming to be true, then these will not form a quadrilateral. That is why they have given if any. Name the type of quadrilateral formed, if any, by the following points. So if they are forming a quadrilateral, then if it's a square, then just now we discussed the properties of a square, then that would be a square. And then for rectangle, the opposite sides will be equal, right? Rectangle has this property that these two sides are equal. So AB, CD When we do that, then AB is equals to DC, AD is equals to BC. This is what we will be checking here. And then um, the diagonals in a rectangle are not equal, right? Are they equal? No, they are equal in rectangle also. Let me just Google it. Even I have forgotten certain things. Diagonals of a rectangle are also equal. Okay, but the sides of a rectangle are some of this type, that opposite sides are equal. Okay, so we are going to do this. And then if you have parallelogram, in parallelogram also opposite sides are equal, but the diagonals are not equal in a parallelogram. Okay, that is there. And then any doubts in sixth question? Saad, any doubts?
No, sir.
No, Zeb, what about you?
Yes, yes, yes.
Yep. Okay, let's see question number 7. Find the point on the x-axis which is equidistant from this point and this point. Okay, the this particular question is going to be a little conceptual, but nothing too complicated here either. Okay, so this is our coordinate axis. All right, so this is x-axis and this is y-axis. Okay, so what we are being told is that we have 2 points in space here. So 2 comma minus 5 would be somewhere here, a 2 comma minus 5, and then minus 2 comma 9. All right, so minus 2 comma 9 would be somewhere, minus 2 and 9 would be somewhere here, minus 2 and 9. So it would be somewhere here. Now we are being told find the point on the x-axis which is equidistant from 2 comma minus 5 and minus 2 comma 9. So what we are being told basically that there is some point on x-axis, okay, somewhere here or somewhere where it is on the x-axis. We need to find this point C such that AC is equals to CB. Okay. So this condition in itself is the solution for our answer. Okay, so let me do this thing for you guys and okay. All right. Let me do this question for you so that you understand. When we mean equidistant, we are literally going to mean equidistant, meaning AC is the distance AC is equal to the distance CB. Okay, literally that. So what will C be? C will be a point x comma y. This is going to be our point that we are going to consider in space. Now, since it's a point on x-axis, we won't take y coordinate because y coordinate on x-axis is 0. Is that right? Right, Zeb?
Sir.
Right, we are talking about a point on the x-axis. So a point on x-axis of this is of this order, x comma 0. Right, so we will write our points down now. A is 2 comma minus 5, B is minus 2 comma 9. Okay, so AC would be 2 minus x whole square plus minus 5 comma minus 5 minus 0 whole square whole root, and then CB would be minus 2 minus x whole square plus 9 minus 0 whole square, right? Observe that I have only used I have not I did not do anything that involved swapping things here. Throughout the both the formulas I use 21 12. Okay, don't swap figures as you like there. Okay, so now we will square on both sides to remove the root. Without removing the root, it won't make any sense to solve the question. So 2 minus x whole square plus minus 5 whole square is equals to minus 2 minus x whole square plus 9 whole square, right? So this would be a minus b whole square. This would mean minus 4x plus x square plus 25 is equals to 4 plus 4x plus x square plus 81. Is it clear up until now, or am I going too fast? It's clear?
Yes, sir. But
Yep.
Yes,
yeah,
sir.
but
Yeah.
why can't we use midpoint theorem, midpoint formula, sir?
We can't use midpoint formula because, buddy, we are not there yet. This is exercise 7.1, so we can't use midpoint formula here. When they're asking us to find this, in this particular exercise, we would be using that. Since Zeb hasn't studied midpoint formula, so I did not use that here. We could have used that also, but we will use that when we get to 7.2. Okay. We can use that also. Doing that or this will give us the same answer. Okay. So this would be uh, x square minus 4x plus 29. This would be x square plus 4x plus 85. Okay, x square will get cancelled on both sides. And let's send 29 minus 85 is equals to 4x plus 4x. 29 minus 85, 85 minus 29 would give you 7 minus 5, 5, 66. Minus 56 is equals to 8x. So x is equals to minus 6 or 7, minus 7. So our coordinate is minus 7 comma 0. All right. So this point is going to be the point that is going to be equidistant from point A and point B. Okay. All right. Is that clear?
Yes.
Yeah. So this particular form next sum here, find the value of y, values of y for which the distance between these points is 10 units. Okay. All right. So Zeb, now tell me how will we form a equation here? We have point P 2 comma minus 3, Q 10 comma y. Okay. We are being told that we need to find the values of y such that the distance is 10 units. So basically what they are saying is PQ is equals to 10 units. Right, Zeb?
Yes, sir.
Right. If we simply solve this problem here right now like this, sorry, 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 Zeb, I did not get you there. Did not understand what you said. I think Zeb is talking to someone at her home. Okay, this is going to be the equation, right, guys? Yeah. Let Zeb come back. We will resume then.
Sir, can you repeat once again?
Yeah, sure. So we are being told find the values of y for which the distance between the points P and Q is 10 units. So this particular y is the y here. We do not know one, value of the coordinate in one point. Okay, but we are being told that the distance between these 2 points is 10. So if we solve this thing here completely, we will get our value of y, right? Okay, let us do that once and that will get clear. But before that, squaring on both sides so that we remove the square root. All right. So that would mean minus 8 whole square plus minus 3 plus y whole square. You're with us, right, Zev?
Yes,
If you
sir.
need to take a moment with your family, it's all right if you need to communicate something. Okay. So this would be 64 plus we will be expanding a minus b whole square or however you want to look at it. So this would be 9. This would be y square minus 6y is equals to 100. All right, y square minus 6y plus 64 plus 9 would give you 73 is equals to 100. Y square minus 6y will give you minus 37, right? Not 37, 27.
How did 6y come from?
6y. We opened up this formula, right? This was minus 3 plus y whole square. So this would be basically y minus 3 whole square. This is y square minus 6y plus 9. Okay. our basic formula, a minus b whole square. Here a is this, b is this. Okay.
Yes, sir.
All right. So if you solve this now, you would get your answer. Okay. So minus 27. How would you guys split minus 27 to get minus 6y again? This would be minus 3 into. Come on, who would give me the answer for this? All right, let me do it for you guys. No competition here. This class is not for competition today. All right. So we can take these values, y square minus 9y plus 3y minus 27 equals 0, right? Y into y minus 9 plus 3 into y minus 9 is equals to 0. Y plus 3 and y minus 9 is equals to 0. Y is equals to minus 3 and y is equals to minus plus 9. Okay, so we have two values of y now, and as you can notice here, the question very clearly mentioned find the values of y for which the distance between the points is 10. Okay, so for both of these values the distance will be 10. Okay, did you get the question, Zeb?
Yes, sir.
Okay, so this topic is not really complicated here. The only thing that is complicated here is the language of the question sometimes. Okay, so let me see if we are done with exercise 7.1 or do we have any questions left in 7.1. Okay, we have two questions left in 7.1. Let me just bring them over here.
Sir,
Yeah, yeah, Omer. Go ahead, man. Whatever you have.
sir,
Mm-hmm. Bolo, bhai, bolo, bolo. Go ahead.
sir, like when I'm doing exercise 8.1, can I use the concepts of 8.3 or 8.2 or 8.3?
You can use while you're solving on your own, but in the exam, when those questions are asked in that particular, context, in that similar, in that same way, then you cannot use them because, I mean, see, exercise 8.1 questions are very small in their nature, but if they are asked in some particular form, then we will have to solve in that particular form only, because board exams are particular about that and board examiners are particular about that, because as you guys go into 11th and 12th standard, you will come across a lot of, if you guys choose by pc, if you choose pcmb or pcm or pcb, and take up preparing neat and JEE, then you will find hell a lot of shortcuts to solve problems that can be solved in a few sentences or a few lines or a few calculations, but you cannot do that in board. So 8.3 is sort of that cheat code for 8.1 and 8.2. So you cannot use them in exam, but you can use them in your spare time to solve them, to understand how they are working together. Okay. All right, Omer. Is that satisfying? Did that answer the question? Omer? Omer, are you done?
Sir, you are lagging.
What, is my voice not audible? I'm not audible. Okay. Am I not audible, guys?
No, sir, you're audible.
I'm audible. Okay. I think there's some issue with Umer's end. Okay. Yeah, there was some issue at Umer's end. Okay. All right, Umer.
No, don't need.
No need. No need for what? I'm audible now to you. All right, he is in his own world right now. All right, ninth question. If Q is equidistant from P and R, find the values of X. Also find distance QR and PR. Okay. I will give you guys a hint. And we will solve this by this. Okay. From this, we'll find the X values. And then we'll find distances QP and QR individually. Okay. All right, and find the relation between x and y such that point xy is equidistant from these 2 points. Okay, now let us do this one question so that you guys can do the upper question and we can end the class here. Okay, so we have find the relation between x and y such that this point is equidistant from these 2 points. So let us name this point p. P is x comma y. Okay, and a is 3 comma 6, b is minus 3 comma 4. Okay, so what we will do here is we will do AP is equals to PB. This is what we are going to do, Saad and Zeb, right?
Yes, sir.
Yep. Are you following, Zeb? This particular thing was clear to you? This problem? Problem number 9?
Yes, sir.
You can do it on your own?
Yes, sir.
Yeah, okay. Let us do this thing. This thing in your higher classes will be called finding locus. This would be the equation of locus. Doing this would give you equation of locus. Okay, so very easy. Again, x minus 3 whole square plus y minus 6 whole square is equals to x plus 3 whole square plus y minus 4 whole square. Okay, I have already squared on both sides. That is why I'm not taking roots here. I have done it mentally. Okay, x square minus 6x plus 9 plus y square minus 12y plus 36 is equals to x square plus 6x plus 9 plus xy, and then this is 4, right? 8y plus 16. So x squared and these terms will get cancelled. And what else do we have? Minus 6x minus 12y plus 25 is equals to 6x minus 8y plus 25. Okay, let us bring all of your constant terms to one side. Okay, so I would be sending all of them here. So this would become 12x, and then this would become 4y, and this would become laga lo, and then 45 minus 25 would be 20 is equals to 0. Okay, this is our required relationship between, okay, these two things. All right, any doubts in this?
No, sir.
No. Okay, so Zeb, we have virtually completed exercise 7.1. Okay, if you have any doubts, we can discuss them in the next class. And Umair, for you and Fasad, since you guys have already done this particular thing, the homework for you would be exemplar, MCQs, coordinate geometry MCQs, 8, 10 to 21. 10 to 21 is there are some MCQs between I think 19 and 20. They are based on areas of triangle, which is not part of our syllabus now. So leave them. Okay, 10 to 21. Umair and Saad. Okay.
Okay.
Okay, sir.
Okay. And for as for Zab, the homework would be the same thing, but the MCQs would be from exemplary. Okay. The MCQs would be, let me just take a look at it. 1, 2, okay, they would be 1 to 10. Leave anything related to ratios. Okay, if any MCQ, you find any MCQ uh, related to ratios, then leave that. We will discuss 7.2 in the next class and then we will proceed ahead. Okay, and as for you guys, Umair and Saad, in the next class, we will be wrapping up coordinate geometry. Okay. And with Zab also being in class, if she is with us, and hopefully we all of us will be here, so we will be wrapping up coordinate geometry. All right, does that work, Zab?
Yes, sir.
Okay, as you can see, the chapter is not complicated and not really lengthy, so we do not really have to spend more time on this than it's necessary to. Okay, so I will see you guys in the next class. Until then, take care of yourself. Okay, let's end the class here. Okay, I will see you guys tomorrow or whenever the class is scheduled. Okay.
Thank you, sir.
Okay, take care. Bye bye.